In the HVACR industry, we use many different types of valves. This presentation is going to cover some of the most common types that we use to control flow. The valves can be ordered with either MPT threads to join with threaded pipe. They can be sweat connections, which is another term for soldered connections, or they can be connected by a flange. On the valves, they will have the term WOG or WSP, or they could have both terms imprinted on the valve along with a number. What WOG stands for is water, oil, or gas. The number is the pressure at which the valve is rated. WSP stands for working steam pressure. The number is the pressure at which the valve is rated for. Valves rated for steam could also be marked SWP or with just an S. Regardless of type, all valves have the following basic parts: the bonnet, the body, trim, which are the internal elements of the valve, an actuator or handle, and most have a packing. For a reliable seal between the stem and the bonnet, a gasket is needed. This is called a packing. A ball valve, which is a quarter-turn valve, has a ball with a hole through it, placed in a passageway through which fluid flows. These valves allow for shutoff or isolation, and for the purposes of controlling the amount of the flow. They do not offer the fine control that may be necessary in throttling applications, but are sometimes used for this purpose. Throttling is a term that is used when talking about controlling the flow. When the ball is positioned so that the hole runs the same direction as the passageway, this fluid simply flows through it, and the valve is open. The ball can also be positioned so that the hole is perpendicular to the passageway so that the fluid cannot pass through, and the valve is closed. It is controlled from the outside, often with a handle that is turned back and forth to open and close the valve. The handle will be in line with the pipe when the valve is open and perpendicular to the pipe when the valve is closed. A full port ball valve is a special valve design that allows for unrestricted flow when the valve is opened. Full port valves have larger bodies than standard valves. This larger body houses larger ball and a larger opening inside. Full port valves have openings the same size as the surrounding pipe. For example, a 2-inch full port ball valve will be compatible with a 2-inch pipeline, and it will have a 2-inch valve opening inside the ball. This is great for applications that require very little to no flow loss. When a full port valve is in the on or open position, it's like there's no valve there at all. Flow is unrestricted. In addition to full port valves, there is also what is called a reduced port ball valve. As you may imagine, this means that the opening in the ball is smaller than full port valves. Actually, it is precisely one pipe size smaller. For instance, a 3/4 inch reduced port valve has a 1/2 inch pipe size ball opening. This smaller opening causes an increase in velocity. Generally, full port ball valves are more expensive than standard or reduced port valves. Depending on the application, one or the other may be beneficial. When it comes to ball valves, though, all serve the same purpose: to provide an open, enclosed function or flow control in the pipeline. If you look at the ball valve in the upper left corner, it is an MPT threaded ball valve. The lower left is a sweat or soldered ball valve, and the one on the right is a flanged ball valve. Ball valves can be positioned in any direction in the piping. Some of the advantages of a ball valve are they're a quick quarter turn on or off operation. They're tight sealing, smaller in size than most other valves. One disadvantage, as mentioned earlier, is conventional ball valves have poor throttling capabilities. A butterfly valve's operation is similar to that of a ball valve, which allows for quick shutoff. The valve is made up of a body, seat, disc, stem, and an actuator or handle. The disc is positioned in the center of the pipe. Passing through the disc is a rod connected to an actuator or handle on the outside of the valve. Rotating the actuator or handle turns the disc either parallel or perpendicular to the flow. A butterfly valve is from a family of valves called quarter turn valves, the same as what a ball valve is. In operation, the valve is fully open or closed when the disc is rotated a quarter turn. When the valve is closed, the disc is turned so that it completely blocks off the passageway. When the valve is fully open, the disc is rotated a quarter turn so that it allows an almost unrestricted passage of the fluid. The valve may also be opened partially to control or throttle the flow. The picture on the left is a flange design. The picture on the right is of a MPT female butterfly valve. Most butterfly valves are bidirectional, meaning they do not have just one direction of flow. Some advantages of butterfly valves are the compact design requires considerable less space compared to other valves. They're light in weight. The quick operation requires less time to open or close. Some disadvantages are throttling service is limited to low differential pressure. Disc movement is unguided and can be affected by flow turbulence. Check valves are flow sensitive and rely on the line fluid to open and close. The internal disc allows flow to pass forward, which opens the valve. The disc begins closing the valve as forward flow decreases or is reversed, depending on the design. They will have an arrow imprinted on the body of the valve showing the direction of flow. Swing check valves are available in either Y pattern or straight body design. In either style, the disc and hinge are suspended from the body by means of a hinge pin. Seating is either metal to metal or metal seat to composition disc. Swing check valve shutoff depends on gravity, weight of the disc, and reverse flow. They are one of the few self-automated valves that do not require assistance to open and close. Unlike other valves, they continue to work even if you lose electricity or the human being that might manually cycle them. Regardless of type or style of valve, the longest trouble-free service will come from valves sized for the application, not the line size, whereby the disc is stable against the internal stop in the open position or fully closed. Unfortunately, most check valves are selected in the same way on and off valves are selected, based on line size. This ignores the fact that unlike on and off valves, the flow conditions determine the performance of the check valve, since its disc is always in the flow stream. As mentioned earlier, unlike on-off valves, check valve internals are flow sensitive. If there is not enough flow, disc movement occurs inside the valve since the disc is always in the flow path. This results in wear and potential for failure. Another type of check valve is the spring check valve. It operates much like a swing valve, but there is a spring inside that will drive the disc closed if there is no forward flow. A spring check valve can be positioned horizontal or vertical. It is not dependent upon the movement of the disc on a hinge. The picture on the left is of a swing valve. Care must be taken that it is positioned so the disc will operate properly. Swing check valves should be mounted in the horizontal position, but may also be mounted in the vertical position provided the disc is opened by the flow and not by gravity. If positioned wrong, you risk the disc being always open because it is controlled not only by flow but also gravity. The picture on the right is a blow-up of a spring check valve. Its positioning is dependent upon the direction of flow arrow imprinted on it. Some disadvantages of a check valve are it's hard to determine if the valve is open or closed because all the moving parts of the valve are placed in an enclosed area. The valve disc can get stuck in the open position. A globe valve is a type of valve used for regulating flow. Globe valves have an arrow imprinted on the body telling which way direction of flow should flow for the valve to operate properly. Globe valves are named for their spherical body shape with the two halves of the body being separated by an internal baffle. The picture on the left shows you an internal picture of a globe valve. The baffle has an opening that forms a seat onto which a movable disc or plug can be screwed in to close the valve. In globe valves, the disc is connected to a stem which is operated by screw action using a hand wheel in manual valves. There are also automated globe valves which have smooth stems rather than threaded and are opened and closed by an actuator assembly. Globe valves are used for applications requiring throttling, flow control, and frequent operation. Since the baffle restricts flow, they are not recommended where full unobstructed flow is required. For applications with low temperature, globe valves are normally installed so that the pressure is under the disc. This contributes to easy operation and helps protect the packing. For applications with high temperature steam service, globe valves are installed so that the pressure is above the disc. Otherwise, the stem will contract upon cooling and tend to lift the disc off the seat. Stop and waste is a feature that can be added to ball and globe valves. The valve has a male threaded port on one side with a cap. The port is most useful when installed on the outlet side of the valve when the valve is in the vertical position. When the valve is turned off, unscrewing the cap or loosening it opens the port, allowing the pipe above the valve to drain as long as air can enter the pipe through an open faucet or by cutting the pipe above the valve. The picture on the right is of a stop and waste. Some advantages of a globe valve are good shutoff capability, moderate to good throttling capability. Some disadvantages are they do not allow for unrestricted flow. In a manually open or closed globe valve, they are not as quick to open and close as some of the other valves. A gate valve is a valve that opens by lifting a round or rectangular gate or wedge out of the path of the fluid. The gate faces can form a wedge shape or they can be parallel. Gate valves are primarily used to permit or prevent the flow of liquids. But typical gate valves shouldn't be used for regulating flow. On opening the gate valve, the flow rate does not change evenly with steam travel. Also, a partially open gate disc tends to vibrate from the fluid flow. Most of the flow change occurs near shutoff with a relatively high fluid velocity causing disc and seat wear and eventual leakage when the valve is closed. Typical gate valves are designed to be fully opened or closed. When fully open, the typical gate valve has no obstruction in the flow path, making the valve a full port valve. Gate valves have either a rising or non-rising stem. Rising stem provide a visual indication of the valve position because the stem is attached to the gate such that the gate and stem rise and lower together as the valve is operated. Non-rising stem valves may have a pointer threaded onto the upper end of the stem to indicate valve position. Since the gate travels up or down the stem on the threads without raising or lowering the stem, non-rising stems are used underground or where vertical space is limited. Some advantages of a gate valve are good shutoff feature. Gate valves are bidirectional and therefore can be used in two directions. Pressure loss through the valve is minimal. Some disadvantages are they cannot be quickly opened or closed. Gate valves are not suitable to regulate or throttle flow, and they are sensitive to vibration in the open state.